Hey everybody, it's Mr. Rozon here. I want to do a small video here on probability using permutations. Probability using permutations. So a permutation essentially is when you figure out how many ways things can be rearranged. So let's say I've got three different objects and I'm going to rearrange them. So I've got A, B, C. And I want to figure out how many ways can I rearrange those. Well, I can rearrange them A, C, B. I can rearrange them B, A, C, B, C, A, C, A, B, and C, B, A. Okay? So there's six different ways I can rearrange those three objects. Now, the number of ways that you can rearrange this is 3 factorial. And 3 factorial, what this works out to is 3 times 2 times 1, which ends up being 6. Now, another way of actually calculating this number is using a permutation. And we can write it out like this. And basically, it ends up working out to the same exact thing. Okay, so this is, I always call this pick. I always read this as 3 pick 3. But it's a permutation of 3 objects chosen from 3 objects. Now, sometimes what happens is you might actually have to pick, let's say, 2 with a 3, not 3 out of 3. So if you needed to grab 2 objects out of 3, then what you would do is you would write 3 pick 2. And you can work that number out. And that one works out to, let me just punch it in. That works out to 6 as well, actually, in this case. Okay, it just happens to work out the same. So when you're picking things or you're using a permutations, what's important to realize is that the order matters. Usually with probability, you got to worry about something called combinations as well. And the rules for permutations is the order does matter that the arrangement goes. Sometimes the order doesn't matter. Like, for example, if you had a deck, a poker hand, for example, and I get you 5 cards, and inside your 5 cards, you find out you have 2 kings in there, right? You say your poker hand has 2 kings in it. It doesn't really matter how you rearrange your hand. You still have 2 kings in it. That is a combination. A permutation, though, is when the order does matter, like this example right here. Let's say this is a password, for example. All these different passwords would actually be unique. Even though they're rearranged and they use the same letters, they're all different. So that's a permutation. So you got to be aware of the difference and when you can use combination and when you can use permutation. So let's do 2 questions where I'm going to work out probability using permutations. So first one is this. So let's say I've got these letters. So I've got A, B, C, D, E, and F. And I want to know what is the probability, what is the, my writing is messy here. Let me try it again. The probability that a 3-digit combo contains no vowels. So combination, or like 3-digit combos, these are like passwords. In passwords, the order does matter where you have the letters. So it's going to be a permutation. So I'm going to show you 2 ways of solving this. So one way you could solve it is with boxes. Okay, so let's figure out how many ways can I make with no vowels here. So if I have no vowels, I basically have 3 boxes I got to fill in for my 3-digit combo. So with no vowels, I'm allowed to have a B, a C, a D, or an F. Those are my consonants. So I got 4 letters to choose from. So in box number 1, I essentially have 4 different letters I can put in here. In box number 2, oh, and by the way, there's no repeats allowed here. Otherwise, it does change the question. No repeating of letters. Okay, so the first box, I was allowed to have 4 different letters in it. The next box, once I use up one of those letters, there would only be 3 of the highlighted ones left. And once I select one for this box, there would only be 2 available for the third box. So these numbers here, they represent the number of choices for each spot. So my first combo, or my first digit of the combo has 4 possibilities. Then it becomes 3, then it becomes 2. Which when you work this out, becomes 4 times 3 times 2, which is 24. Now with all letters possible, if we do the same style here, the first digit, it could be any of the letters, A, B, C, D, E, and F. There's 6 of them there, right? So 6 possible choices for the first letter. Now, one of my letters has been removed. So how many letters are left? There are 5 letters left. So 5 letters could go here. And then finally, there would be 4 letters available for this location here. Work this out. This becomes 6 times 5 times 4, which ends up being 120. So if you work this into a probability question, the probability of getting no vowels would be 24 possible combos out of the 120. Okay? And that works out to 0.2, which is 20%. Now, the way I just solved this on the left, this is something that's more called the fundamental counting principle. You're using this box. I like to use boxes to solve these type of questions, but there is a different way of doing it, and sometimes it's easier to use a straight formula. And what you can do is, for the one with no vowels, the way you can think of this, no vowels. The way you can think of this is, of my consonants, there are 4 of them, right? So out of my 4 consonants, let's pick 3 of them. Okay, 4 pick 3. And for the all letters is going to be, there's 6 letters there. Out of the 6 letters, let's pick 3. So as long as I'm not having repeats or anything like that, I'm allowed to use these formulas. And these, you can just straightforward punch in your calculator. So if you actually work out 4 pick 3 over 6 pick 3, that gives you the same exact thing. You'll get 24 out of 120, which will give you 0.2, and it's 20%. So that is a probability question where I used a permutation. So a permutation, basically what you're doing is, out of a collection of n objects, you're selecting r of them, and the order does matter. So again, for no vowels, there's 4 of them. I'm going to pick 3 of them. And out of all of the letters, there's 6 of them. I'm going to pick 3. And we make this into a probability question by turning it into a fraction. So I hope this makes sense in how you can do probabilities like this. I do want to do one more example here, a little bit more complicated. Okay, so here's the last example. So what is the probability that a randomly generated 7-digit phone number contains no zeros and repeated digits are not allowed. Okay, so what's the probability that a randomly generated 7-digit phone number contains no zeros and repeated digits are not allowed? Okay, again, I'm going to show you 2 ways to solve this. I will show you with the fundamental counting principle, and then I'll show you an easier way with permutations. So if we've got a 7-digit phone number, 1, 2, 3, 4, 5, 6, 7. I think that's 7 there. So how many ways can I make my phone number with no zeros allowed? So no zeros. So if you think about the numbers, all the digits allowed, we got 0 up to 9, right? So if we remove the 0, that means there are actually 9 digits. Because 0 to 10, or 0 to 9 is actually 10 digits if you actually count it. That's 10 digits. So if I remove all the zeros, I'm allowed to use 9 different digits. So in my first location, my first box here, I can have any of the 9 digits that's allowed. So I have 9 possible numbers that could go there. Now it does say that repeated digits are not allowed. Repeated digits are not allowed. So whatever I put in the first box, it can't be the same number in the second box, which means I now am allowed to have 8 digits possible here. Because I can't use a 0, and I can't use the 1 from the first box. Now box number 3, I could use anything, but I can't use a 0, and I can't use the 1 from number 1, and I can't use the same digit for number 2. So there's 7 that are allowed here, and then the next one would have 6 allowable ones, 5, 4, and 3. And if you actually work this all out, this ends up being 9 times 8 times 7 times 6 times 5 times 4 times 3. This ends up being 181,440, like that. Now, if you're working this out as a probability, right? It says what's the probability that a randomly generated 7-digit phone number contains no zeros? Then what we got to do is we got to divide this number by the total number of phone numbers that are actually available. So all numbers, the way this would work, very, very similar. 1, 2, 3, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. The way this would work is we're going to be able to generate a number including zeros. We're allowed to use zeros this time. Okay, this is the total number of phone numbers allowed. So for the total phone numbers, if we're allowed zeros, that means it would be 10 digits allowed for the first one, then 9, then 8, then 7, then 6, 5, and 4. Work this number out, and you multiply them all together, you're going to get 604,800. So now, because it's a probability question, we have to turn this all into a fraction. So the probability of no zeros would equal 181,440 over 604,800, which gives me 0.3, and there's my answer. So that's a way of doing it using the fundamental counting principle with boxes. Now to do the same question, but we use permutations, it's a lot easier. What you have to know is this. For a phone number with no zeros, it would be this. Out of 9 allowable digits, let's pick 7 of them. That's for our boxes. And we're going to divide that by the total number of ways of making the phone number. The total number of ways of making a phone number is this. Out of the 10 possible digits, let's pick 7. If you work these out, you will get the exact same thing I got on the left. So this works out to 181,440 over 604,800, which gives you 0.3. But it's a lot simpler. It's a lot easier calculation. In your calculator, you literally just punch in 9 pick 7 divided by 10 pick 7. You're going to get 0.3 and you're done. So that's a simpler way of working this question out. So whenever you work out permutations, if you turn them into fractions, that's what you have to do for probability type questions. So I hope this lesson is a little bit useful. I hope you learned a little bit about permutations here and the fundamental counting principle and how they relate to permutations. And yeah, hopefully you found this thing useful.